Right, I'm going to take a little longer on 10.4 number 1 just to kind of go through a really good explanation of logarithms and exponential equations so that you'll understand it, and then we'll start kind of moving at a faster pace. When you see a logarithm is an exponent. This is equal to some missing exponent. Usually we call the missing exponent, I'm going to call it C, okay? So instead I should have put just log 5, 125 equals C, okay? So this is a missing exponent here. Now, what a logarithm is, it's the inverse function of an exponential equation, okay? So, a lot of times we look at logs and we go, that doesn't look familiar to me, I don't know what to do. So what we can do is this kind of a weird little thing with logarithms and exponential functions. We can rewrite the logarithm as its exponential function inverse and figure out what it's equal to. So here's what I do. I use a little memory device that seems to help people. Pretend you're on a pirate ship, and the pirate ship has an alphabetical logbook of, what they've plundered, okay? And they put it in alphabetical order. Well, this is the pirate logbook, and it's in alphabetical order. There's a little a, that's the base. Big B, C is the missing exponent, okay? Now, why is that going to help me? Well, if I rewrite an exponential function, for instance, you've seen exponential functions like it written y equal 5 to the x, right? Well, what I'm going to do instead of using y's and x's is rewrite it with these a's and these b's and the c's, okay? And I'm going to write a to the c power is b. And remember, we're on a pirate ship, so the pirate, he's looking out, looking for land, and all of a sudden he goes, I see a bee. Okay, I see a bee. Duh. Okay, so he's close to land, so the bee's flying out. He knows he's close to land now. Anyway, I, like A, C, B. I see a B. You write it in that order, okay? Now, here's what we can do. If we have labeled our log function over here with the A's, B's, and the C's, we can put them over here and figure out what the missing exponent is. My A here is 5. So I'm going to rewrite this log as an exponential function. I'm missing, okay, my B is 125. That goes on the other side. And my C is my missing exponent. 5 to what power is 125? Well, if you don't know, 5 times 5 is 25, times another 5 is 125. So that was 3 5s. So the missing exponent is 3. That's how we figure it out. We know a whole lot more about exponents than we know about logs. Logs are kind of an unknown thing in our brain. So this is how you can figure it out. Now, a lot of people don't have to go to the trouble to rewrite it because they kind of go do this. I'm going to circle things as I go. Log 5, 125 is what? If you do this, if you go, okay, I start off with 5, and then the missing exponent's on the other side. I don't know, I hit the wrong button here. 5 to the missing exponent is equal to this number right here, 125. So you kind of start on the left, you say 5, you go all the way to the right to the question mark, exponent is equal to the number in the middle, 125. And so then they go, oh, that's 3, and they could just write the answer down and circle it. That's a faster way to do it than rewriting it, but if you need to rewrite it, a lot of people rewrite it because it just helps them get the right answer. Let's look at some more. Okay, number 7 says log 5, 125. I'm going to put a C here because we know that we want the missing exponent. And the quick way to do it is to say this little base 5 to the power of the C, the missing exponent, gives me that number 1 over 25 in the middle. Or I could label it. I could say, okay, we're on the pirate ship. It's an alphabetical logbook. A, B, C. Remember, I put this in here. There wasn't anything over there, so I always just call that C. And I'm going to change that to I, C, a B. Okay? All right. So my A here is 5. My C is my missing exponent, so I'll just call it C. And my B is this 1 over 25. Okay. Now we had a problem like this back a couple of sections ago. You know, if you had 5 squared, it would be 25. How are you going to get that 25 to the bottom of a fraction bar? Because that's what's happened. It's on the bottom, isn't it? Well, do you remember that if you put a negative on the exponent, that's how you move it down to the bottom? So what is my missing exponent here? It is negative 2. The negative 2 would move the whole thing down to the bottom, and 5 squared would be like 5 over negative to the negative 2 power. It would be 1 over 5 to the second power, which would be 1 over 25. That's how you have to think about it. There is no magic way other than that to solve it. It is a logic process, okay? Looks a little weird, I know. Log 6 square root of 6. Okay, and I'm going to go ahead and put equals C. Now, first of all, I look at this and I think, oh, wow, what is this 6 squared of 6? 6 raised to what power is 6 squared of 6? Okay, here's what I would do. First of all, let's change it over. Let's go ahead and label it log A, B, C, and then we're going to say I, C, a B. A to the C power is B. A is 6. C is the missing exponent. And then we have 6 square roots of 6. Now, logs are exponents. And if you remember, your square roots can be written as exponents. So let me rewrite this. Let me come over here and do a little figuring, okay? 6 squared is 6. That's 6 to the first power. And square root of 6 is 6 to the 1/2 power, right? I could rewrite that square root of 6 this way and remember that this 6 is 6 to the first power. When I multiply with the same base and I have exponents, I could add those exponents. So that would be 6 to the 1 plus 1/2 power. We would write that 6 to the 3/2 power, okay? Because 1 1/2 is 3/2. So let me do this. What if I rewrite that now? What if I take this out and replace it with this other representation of it? Now do you see what the solution is? What is your missing exponent? Oh, it's this right here, isn't it? My answer, my missing exponent, which I'll just keep calling C, is 3/2. So you're getting some practice here rewriting things from radical form into fractional exponent form so that you can actually solve some of these. Look at, how about 13 looks a little weird when I look at it. Log 7 cube root of 49. Okay, now this whole expression, despite all its weirdness, is equal to some exponent. That's what a log is. A log is an exponent. It is a missing exponent. Okay, so let's see. Let's label this. This is an alphabetical logbook, so this is A, B, C. And I'm going to rewrite it as I, C, a B. Okay. My A is 7, my C is my missing exponent, and B is the cube root of 49. Now that looks pretty weird, doesn't it? All right, let's remember that we've got a radical here, but we're trying to think about exponents, and they may be fractions. So those radicals don't help me so much. So I'm going to rewrite the 7 to the C and leave it alone. But do you remember that if you take the cube root of 49, that's the same thing as 49 to the 1/3 power? Now, we had some problems like this earlier in chapter 10 also, and we look at this and we go, well, I don't know what to do. They're not, you know, if they had the same base here, I could do something. Well, they don't have the same base, but we can make them have the same base, because if you think about it, isn't 49, couldn't I rewrite 49 as 7 squared? I can rewrite it in terms of the 7 over here. It is 7 squared. So now what do I have? I have 7 to the C power is 7, and remember when you have an exponent to an exponent, you multiply. So that would be 2/3. Now that I have it written like this, do you see what the solution is? What was the missing exponent? The missing exponent, C, is 2/3. And the reason I can do that is now my bases are equal. C is 2/3. The answer to this question is 2/3. I know this is kind of going backwards, but I wanted to look at number 5 just because a lot of people have trouble with ones like number 5. If you look at this one, if you say, okay, this log is a missing exponent, I'm just going to call it C, okay, since usually my missing exponent is C, and I'm going to label it log A, B is equal to C, okay? Now I'm going to rewrite it, I, C, a B, in its inverse form. The A was a 3, the C is the missing exponent, and the B here is 1. 3 to what power is 1? Well, I don't know if you remember this, but anything at all to the 0 power is equal to 1. So what is this missing exponent? It is a 0 because 3 to the 0 power is 1. Therefore, my answer is 0. The missing exponent is 0. I'm going to do another example that's not in the book, but just in case, I'm hoping we did one like this in class, but just in case I didn't. What if you had log 6? What would the answer be to that? Okay, let me go ahead and put a log is a missing exponent, so I'm just going to say equals C, and I'm going to call the missing exponent C, and I'm going to label this log A, B equals C. Yes, if you're confused, this is not any number at all. This is an extra example I'm throwing in for understanding, okay? I'm going to label it, and I'm going to rewrite it as I, C, B. My A is 6, C is my missing exponent, and my B is 6. 6 to what power is 6? Oh, 6 to the first power is 6, right? So what is my missing exponent C? My answer is 1. Now, what does that mean? That means if I had log 123 of 123, if these two numbers right here match, the answer is going to be 1 because 123 to the first power is equal to 123. So anytime you see the same number here and the same number here, your answer is going to be 1 because any number raised to the first power is itself.